what life stage you're talking about, as far as, just going from, say, egg to the fish emerges and successfully emerges to, say, a fry. That could range anywhere from, just depending on the habitat conditions, but let's say in suitable habitat conditions, as far as sediment and things like that, it might be 40 to 60% or something like that. Make it just to the fry stage, but then there's just a whole host of other things that come into play, and to adulthood, and if you are talking about how many actually make to a point where they actually reproduce again, it's a pretty small 1% or 1% or something really small, depending on the species. And when we do trout in the classroom, most of the eggs hatch, but they start dying once they emerge, and then they have to try to feed, and then they're affected by water quality and whether they got enough food. And okay, so generally I'm going to talk kind of more in general about habitat, and then kind of focus in more on some little details of habitat. So when we're talking about habitat for salmonids around here, they use a wide range of habitat, everything from these small streams, small mountain tributaries, to these large alluvial or valley bottom streams. Canyons like this one on the middle fork of the Salmon are often corridors for migration, compared to this might be spawning habitat. And like I mentioned before, they'll use lakes. So over a large scale area, they use a lot of different habitats, from small streams to lakes to large rivers, and then even the ocean in the case of anadromous fish. And I'll talk about this a little bit more, but depending on the life history stage that they're at, they'll use these different habitats. And then there's the seasonal habitat use, all the way from spring, when flows are really high, to summer, fall, and winter. You can imagine that fish would use different habitat in the spring when it's really high and flooding, versus in the winter when they just need to find the deepest pool to hang out in, because they're not going to hardly feed or be very active for a few months. So the types of habitats that they need during the different seasons changes with the seasons. And if you're a spring spawner, the conditions of the habitat in the spring are important. If you're a fall spawner, the fall conditions are important. Okay, now sort of drilling down a little more specifically on talk kind of generally about these different types: small streams, lakes, bigger rivers. Now within a stream, we break down the different types of habitat and talk about how they are important to fish. So first there are riffles. This is an example of a riffle, kind of shallow, fast moving. They're usually really turbulent, and through that turbulence you get a lot of oxygen in the water. Because they're shallow, they tend to produce a lot more algae, and then the algae, because of the solar input, and then the algae produces a lot of insects. So they're very productive for producing insects that end up downstream where fish are in these pools. And so pools are those deep sections of water. They can be formed by scouring or by dams, like a beaver dam or a log woody debris jam. They provide cover and resting area for fish and winter habitat. So oftentimes a riffle might be too shallow or too high velocity for some fish or some life stages of fish, but they might use these pools to wait for the insects that are coming down from those riffles, and then they feed on those insects So they're both important. You need a lot of pools, but without the riffles producing more insects, you won't have as good a productivity. And just sort of a hydrology comment, the pools are formed, usually pools and riffles are formed during high flow events, and riffles are depositional areas during high flow events, and pools are scour areas during high flow events, like floods. And then there are these lateral habitat areas, which are really important for juvenile fish. They're kind of the margins that are shallow and shallow, so that these small fish are out of the main velocity and they're away from the predators. And then this movie is kind of cool because you probably have heard about an edge effect, especially if a wildlife biologist gave any presentations. This edge effect in ecology is a term for these places in the environment where you have a dramatic shift between different types of habitat, like maybe an open meadow to a forest. And right on that edge, you tend to have a lot of biological activity, a lot of diversity of species, because they're crossing over between the meadow and the trees. Well, this movie shows an example in my mind of kind of an edge effect in a stream where you're on the edge of the main channel, which is pretty high velocity, and then a lateral area, which is really low velocity. And it's kind of the best of both worlds for a lot of these juvenile fish, because they're getting food coming in from the main channel, but that they're able to hang out kind of this safe zone where they can get over into the lateral area. So there's a lot of different species all using this one habitat. This is a bull trout right there. These are little Chinook. That's probably either a red band or a cutthroat. They're hard to tell apart when they're that size. These are, these are little juvenile whitefish. And you can see they have the little par marks when they're that size. So the main channel is out there where it's really deep, and I'm basically laying in this side kind of lateral area that's almost no current, and they're right on the edge. There's that bull trout. It's just another example of one of those kind of off-channel lateral areas. There's a lot of cover and lower velocity. And here's some juvenile Chinook, again using one of these lateral areas.
I was just wondering, is the sound during that movie, is that just what's picked up with the camera on the water and all?
Yeah.
I am curious, are you going to talk about, or help me out here, I have heard, and I don't know for a fact, do trout, or do they eat the smaller trout or each other? Or So that area, I mean, is there a particular time when they're more susceptible to do that? I mean, the movie you showed there, you showed all sorts of diversity, or sizes of fish, different types of fish.
Right.
Would they be feeding on each other at that point, or they're not, there's enough insects that they wouldn't do that, or how's that work?
I think it's really just as they get larger, as you get large enough that you could eat. I'm pretty sure that bull trout would have eaten some of those whitefish, and it had actually made a move at one of those little Chinook So it's really just what they can get in their mouth. And so,
So it's fair,
Yeah.
so it's fair game all the time.
yeah, I mean, the whitefish, yeah. And I think if you were in there at night, some of the bigger bull trout and especially bull trout might start moving up into the shallow areas to feed on some of those smaller fish.
Okay, thank you.
So talked about pools and riffles and lateral areas, and now I'm going to talk a little bit about some of the other features in fish habitat that provide complexity to the habitat. And when I talk about complexity, imagine like a cement lined ditch. That's about as simple as you can get. There are no pools and riffles. It's just there's just the stream flowing down that ditch, and versus a complex habitat that has lots of diversity in pools and structure like wood and undercut banks. And well, wood is a really important feature that provides diversity or complexity to fish habitat. These are just woody debris jams. This one is in part probably due to the wildfire that happened and trees falling in. This is just kind of a mature forest, but you still get trees that fall in. This is an example of a piece of wood that created this pool. Basically the water pouring over scours out a pool below it, which provides habitat, and then you have a riffle. These bull trout are hanging out, getting ready to spawn. They're hanging out right underneath this piece of wood that's providing cover. Another feature of wood is that it temporarily stores sediment. Basically just creates a dam and sediment stores temporarily. And then wood provides nutrients and food for insects, which you then feed fish. These are just some other examples of different types of channels where you have different things form that complexity. In a meadow channel like this, you'll have undercut banks and a lot of slow moving water with probably vegetation growing underwater that provides habitat. In a rockier boulder dominated stream, the boulders will form cover for the fish. And even this plunge and these bubbles create some sort of cover from overhead predators. So here, I'll show you a video of an example of some juvenile fish using this kind of habitat. So this, you can tell it's really low velocity, sort of, it's a pool, but not a really big deep pool where you'd have a lot of other big fish as predators, and just perfect for these little guys, which are probably West Slope cutthroat trout, but you can't really say for sure. They could be juvenile steelhead, juvenile red band. But this is perfect for them because it's real low velocity and they can sit there and pick food off the surface. But if a predator came along, they could scoot over into the really, really shallow water. But just upstream of this, where the pool was deeper, there were larger fish, using that bigger habitat. And so they're sort of segregating in where they hang out. And then sort of a different example in more of a boulder-dominated, deeper pool. You have larger, these are West Slope cutthroat trout, taking advantage of a deeper pool with larger rocks for cover. And There's lots of places for them to hide back in the boulders, or it's actually a bunch of large weird debris at the head of this pool, and they can go back under that. That's a tributary to Big Creek. That's why there's so many West Oak cutthroat trout in Big Creek. It's good habitat for rearing. So now, riparian areas. Riparian areas are another feature that's really important feature of fish habitat, but it's not necessarily in the stream or lake, but it's the area adjacent or zone adjacent to the stream and lake that has particularly important influence on that water. Riparian areas provide shade. The trees and their roots provide bank stability for the stream banks. The riparian area can provide cover, just a lot of overhead cover. Nutrients as far as leaves and organic material falling into the water. Water storage and release, especially like a meadow is, a stream that flows through a meadow. The meadow is like a big sponge that'll absorb water and hold on to it and release it slowly. Terrestrial insect food source, the bugs that fall off, really important source of food for fish, especially in really small headwater streams where there hasn't been a lot of opportunity for algae to grow and then insects to grow in the water. So then it's really important to have insects falling in that they can feed on. Large woody debris that falls in can be a buffer to sediment coming in from the slopes that gets trapped by the vegetation. So just some examples of different riparian areas, and this was an example of that trees providing bank stability, and it's actually the channel's is cutting under that bank, which provides a great place for fish to hide, but the bank is still attached. This is just some examples of wood that was provided by the riparian area, and then the shade. Riparian areas are typically a hot summer day. You go down by the creek and it's nice and cool, really cool, damp microclimate. This is a stream that flows more through a big broad floodplain, and riparian areas are important in streams like this where they are part of the floodplain, because as the river floods it deposits material out in the floodplain, and things are happening out there as far as nutrients being cycled, and then when it floods again it picks up those nutrients and carries them downstream. So that interaction between the floodplain and the channel is an important feature of a riparian area. And water quality, what condition is the water that in, basically. Water temperature is a really important factor, especially for any of these cold-blooded organisms that their metabolism depends on what the water temperature is. So if it's too warm, they'll die. If it's too cold, in the winter, they need to basically just slow down and not do much of anything. Oxygen is really important for salmonage. They need a lot more oxygen, closer to basically the saturation level of oxygen. A lot more than, for example, a carp. It doesn't need a whole lot of oxygen compared to a salmonid. pH is important to be just around neutral typically. Turbidity and sediment are important factors in their habitat. Sediment, for example, when you have increased sediment, I've talked about their spawning and the eggs in the gravel and the alevins in the gravel. Well, if there's too much increased sediment, I can fill in all the spaces between the gravel and reduce the survival of the eggs